Quality of service has been discussed in earlier modules, and we know that quality of service implies that a network gives the desired performance in terms of delay, throughput, packet loss, and monetary requirements to the users, which is specified in a service level agreement. Quality of service routing, which is essentially a routing algorithm for providing VIP kind of paths for source destination pairs, is of interest here. In this module, we shall first understand what do we mean by quality of service based routing, also known as QoS routing. We'd look at a specific application scenario in which the audiovisual traffic has to be routed over some delay bound and throughput specified paths. Then we'll see what kind of support INET framework gives us in OMNET++. Chaudhry Shafiq Ahmed and others, in their well-cited paper called NetSAC, Network State Adaptive QoS Provisioning for MNAs, is a good reference that I opted to choose and include in this module. The design and simulation of a QoS guarantee model for mobile ad hoc networks is another good paper that was published in SATNAC 2006. And the URL refers to the support for differentiated services in INET by the OMNET++ community. So what is QoS routing? If the traffic is classified into best effort, bronze, gold, platinum, and diamond services, each class of traffic would need a minimum bandwidth path. And if that bandwidth is not available, or if the paths offering such bandwidth change with time, it is likely that oscillations might start for such traffic flow. Using quality of service aware routing, we use the modification to the routing algorithms. We shall see that through an example. The key idea is to establish routes that continue to use the previous links till the new paths are discovered and a kind of hysteresis is implemented such that oscillations do not happen. The assumptions made in NetSAC are, let's assume that the minimum bandwidth requirement is 50 kilobits per second, the maximum being 100 kbps. The time for the flow transmission is 1 minute. The weighted representation for the delay and the packet loss ratio are 0.2 and 0.3 respectively, and I is an incremental counter at 65 kilobits per second. Using these values, we can select the threshold which is going to determine if the route under consideration has to change or not. So our goal is to implement QoS routing, which reserves the resources along the path that are equal to 75 kilobits per second, or if that's not available, reserve the resources to 65 kilobits per second, or offer at least the minimum bandwidth at 50 kilobits per second. This is implemented at every router. If the resources are reserved equal to 75 kilobits per second, when the destination node receives data rate less than 75 kilobits per second, it means the network is not keeping up in provisioning the required data rate for 1 minute, that is the observation period. It shall notify the source. The source will then establish a new route with data rate more than S kilobits per second. Since 75 kilobits per second has not been achieved, so the value of S is going to be now 65 kilobits per second. If no such route is available, a route with data rate more than I or minimum bandwidth will be set up. These are going to be the other two conditions. If the resources are reserved up to 65 kilobits per second, and again, if this particular path fails to deliver 65 kilobits per second for the period under observation for 1 minute, again the source shall be notified and an alternate path shall be chosen. If again no such route is available, then B minimum has to be agreed with. And this is what is shown in the last part of the decision. There is support for differentiated services in particular, and a baseline support is also provided for integrated services. Let's talk about the differentiated services. Since differentiated services implements the queue management as scheduling and drop preference, the current queuing models supported in INET are the drop tail queue, drop tail quality of service queue, which is multiple queues, and random early detection. INET also supports the differentiated services code point classifier as the basic DSCP classifier. If you implement classify by DSCP, it creates new packet classifiers. It means looking at the 6-bit value of DSCP code point, various classifications of traffic can be realized.